Tonight's video is going to be about concentration of solutions, and it's section 4.5 in the book, and it's going to roll in three topics that seem to be unrelated, but they are actually pretty related, and they're all going to roll us into solution stoichiometry, which is coming next. But let's start off with our easiest way to quantify concentration of solutions, which is the idea of molarity. And this is a concept from General Chem, and we're going to revisit it here. Molarity. Now, molarity is going to be equal to the moles of your solute, and solute being the particles that are dissolved in the smallest amount, divided by liters of solution. And we have to make sure that we're in liters when we deal with molarity, even though quite often they'll throw problems at us where they give us milliliters and we've got to convert to liters. So let's take a look at a quick problem here. Okay, so we're looking for the molarity of a solution made by dissolving 23.4 grams of sodium sulfate Na2SO4 in 125 mils of solution. So a couple of things that we need to do here. One, we're going to use the formula, or the equality rather. 1 liter is equal to 1,000 milliliters, because we need to take our milliliters and convert them to liters. So let's do that real quick here. So we have 125 milliliters and 1,000 milliliters and 1 liter. So really all we're doing is sliding the decimal place 3 places to the left. 0.125 liters is our correct answer there for liters, and we can go ahead and plug that into our molarity formula, which we'll do in a second. Next, we were given 23.4 grams of sodium sulfate, and we cannot plug that directly into our molarity formula because we need moles. And so what we're going to do is we're going to convert to moles, 1 mole of sodium sulfate, and we need to calculate the molar mass of Na2SO4. Molar mass of Na2SO4 is 142, and that gives me 0.165 moles of Na2SO4. And now all we need to do is use the molarity formula. Molarity equals moles of solute over liters of solution. So we're going to have 0.165 moles over 0.125 liters, and that gives us an answer of 1.32 moles per liter, or molarity. Either one of those is the correct unit, and they're used interchangeably. We always have to remember that molarity is moles per liter. Okay, our next talk real quickly here is calculating molar concentration of ions, and this is the one that's real similar to calculating moles of atoms within a compound. So let's say we have a 1 molar solution of, we'll use the sodium sulfate, which is the same chemical that we used in the previous example. If we were to break this up into ions, we'd obviously have we'd have our sodium ions, and we would have our sulfate ions, and this guy would break up if we put it in water because it's definitely soluble. Now, the molarities, though, is we have 2 sodiums here, so we would have a 2 molar sodium sulfate because we started off with 1 molar, and we'd only have 1 molar with respect to the sulfate ion. So I'm sorry, I said 2 molar with respect to the sodium ion there. Let's correct that there. And that's kind of the same as what we dealt with when we were dealing with our moles of atoms within a compound. Let's look at another example real quickly, as this is not a very difficult concept to deal with. So let's say if we have a 0.0125 molar solution of calcium nitrate, we could ask what is the molar concentration of each ion. And so we'd have to first, of course, write the formula for calcium nitrate. Calcium is 2 plus charged nitrate and 1 minus. And so then if we were to break that guy up into ions, we would have our calcium ion, which is 2 plus we'd have our 2 nitrate ions. And so the molar concentration for the calcium ion would be 0.025 molar, and then we would just have to double that for the nitrate, and so we would get 0.05 molar for the nitrate ion. And that's all we really need to worry about that. And that's going to come up later on for us. The last thing we're going to talk about tonight are dilutions and dilutions problems. And the couple words that get thrown around with dilutions, one is the word concentrated and dilute. And this is referring to solutions. Concentrated solution is going to be the solution that has the greater molarity. So the greater your molarity, the more moles you have per liter. So we're going to say it's concentrated. The dilute obviously is going to be our smaller molarity when comparing two. So let's jump over to the next page here and let's show you how to do a calculation involving this. So there's a formula involved here. It's going to be molarity of concentrated solution multiplied by volume of concentrated solution is equal to molarity of our dilute solution multiplied by our volume of our dilute solution. And so this is a really important formula that we just need to commit to memory because it's not included on our equation sheet, but it comes up sometimes when we need to deal with molarity and volume calculations. So let me show you what it looks like when we have one of these problems. Okay, so we have how many milliliters of a 2.5 molar HCl solution are needed to make 250 milliliters of a 0.5 molar solution. So a couple of things we need to recognize here in this problem. One, the greater molarity is going to be our molarity of our concentrated. And then these two values here, the 250 mils and the 0.5 molar solution, are basically tied together. And so this is going to be our volume of our dilute, and this is going to be here our molarity of our dilute because it's the smaller of the two concentrations. And you see how the kind of a 0.5 molar solution ties those two numbers together. So we're just going to use the formula molarity of concentrated multiplied by volume of concentrated equals molarity of our dilute multiplied by our volume of our dilute. And we're just going to plug in the three of the four variables that we have. So we have the molarity of our concentrated, which we knew is 2.5 molar. We don't have the volume of the concentrated, which is what we're looking for in this problem. We're going to plug in our 0.5 molar solution multiplied by our 250 milliliter solution, and then we're just going to solve it for volume of concentrated. Divide both sides by 2.5. And that's going to cancel out our molarity, and it's going to leave us with an answer in milliliters for an answer. And so we multiply and then divide, and we get 50 milliliters as our correct answer for how much of our 2.5 molar HCl solution we need to measure out. Just a little hint for this. If you're ever given liters as one of the volumes and you're solving for the other volume, your answer is going to come out in liters. No big deal. We can interconvert between milliliters and liters. So just watch what we're doing with our units to make sure that we have matching units for our answer. And that's all we have for tonight, a short lecture. Have a great night.